Hello learners and my viewers, welcome once again to my YouTube channel, Physics Hub 254. So today learners, we have a question here. The question is coming from a topic in Form 2. The topic is known as turning effect of force. The turning effect of force. And we have a question. The question goes by, a uniform plank of wood weighing 40 Newton and of length 7 meters is suspended by two ropes, Q and R. Q, that is rope Q, is 1.5 meters from one end of the plank, while R, that is rope R, is 2 meters from the other end of the plank as shown below. So learners, this is the diagram. The diagram has represented everything that is on the statement above. This is Q. It is 1.5 meters from this end. This is our rope R. It is 2 meters from this other end. Next, we are told that a metal block of weight 20 newtons is suspended from the center of the plank. So there is this metal block whose weight is 20 newton and it is suspended at the center of the plank. The question is, calculate the tension on each rope. So we are expected to calculate the tension on each rope. Now, this is the approach we are going to give this question. First, I will get the tension on rope R. So I start by saying tension on just R. If I want to get the tension on R, I will take moments about point Q. I will take moments about point Q, this point here, which I'm also calling point Q, because it's where the rope Q is attached to the plank. I'll take moments about this point. When I say I'll take moments about that point acts as my pivot. It is now my pivot. I assume that this is my pivot so that I can have the total downward forces and the total upward forces. Remember, tension force here is acting in this direction. It is directed towards the fixed point. This point is the fixed. So we have this upward force, which are calling the tension force. We have the downward force. The downward forces here comprises of two things. One, it comprises of the block, the metal block that was suspended at the center. Two, there is another force acting along this point. And this force is the force which is simply the weight of this wooden plank. This wooden plank weighs 40 newton. Weight of a body normally acts at its geometrical center. The geometrical center of this plank is at the center here, which means if the plank is 7 meters, it is acting at a point 3.5 meters from either sides. So the distance from this point to this point is 3.5. That is the half of 7. So that 3.5 centimeters up to this point. The same with this other side. Of course, 3.5, not centimeters, but meters, meters up to this other point. Another thing, the weight is still acting at the same point, so I can show. The weight here is 40 newtons. So just like I said, when getting the tension on R, we take moments about this point here, which I'm just calling the point Q, because where the rope Q is attached to the plank. Now, the principle of moments states that a body in equilibrium, for a body in equilibrium, the total anti-clockwise moments about a point is equal to the total clockwise moments about the same point. That is, the sum of clockwise moments about a point is equal to the sum of anti-clockwise moments about the same point. So that is the principle of moments. So that's what we are going to use here. So I'm going to take this one to be my pivot. So that's like taking moments about this point Q. So taking moments about Q, the sum of clockwise moments about point Q is equal to the sum of anti-clockwise moments about the same point Q. So we have those moments. A moment is just about the product of force and the perpendicular distance between the line of action of the force and the point of support. So if I want to know those forces that will make this plank, if this is the turning point, there are those forces that will make it turn in the clockwise direction. There are forces that will make it turn in the anti-clockwise direction. So let us start by calculating the moments of force in the clockwise direction, meaning downwards. And the forces are these. A combination of these two, which is just the same as 60. The total downward force here becomes 60 newtons. So 60, I'll multiply by the perpendicular distance between the line of action of that force and the point of support, meaning the distance between this point and this point, which is simply 3.5 less 1.5, so that I get the distance here. This distance is simply 2 meters. So I'll take 2 times 60 equal to, there is no any other force that is producing clockwise moments here, so I will not add anything, though the statement is the sum, but we don't have any other force, so we only have one force producing the clockwise moment, is equal to the sum of anti-clockwise moments about the same point. So this tension here, this tensional force here, is the force that will bring anti-clockwise moment. So we call it TR. I multiply it by the distance, the perpendicular distance between the line of action of that force, this line, and the point of support here. So I need to get this distance. For me to get this distance, first I know I need to get the distance from this point to this point. The distance from that point to this point, because the whole of it from this point is 3.5, this is 2, and then this one becomes 1.5 meters. So the distance from the point of support and the line of action of this force is the sum of these two, which is simply 3.5. So I'll multiply by 3.5. So this one becomes 120 equal to 3.5 TR. 3.5 TR. Then I divide both sides by 3.5. 3.5. Let me have my calculator. Now, this one will cancel out so that we have TR equal to, the TR will be equal to 120 divided by 3.5. So I get 34.29. 34.29 newtons, because it's a force. That is the tension on rope R1. To get the tension on rope Q, the tension on rope R is that. Then to get the tension on Q, T, Q. We can do it in two ways, but if you give it this approach again, it is going to waste a lot of time, because we also have to look at the time factor during exam. We are just going to say that because this body is at equilibrium, the sum of upward forces equals the sum of downward forces. So when we want to get that one, we are going to say that upward forces equals to the sum of downward forces. Now, our upward forces is this force and this force. So TQ is what we are looking for. TR, that is the tension of R, we already calculated. It is 34.29. This one should be equal to the sum or the total downward forces. The total downward forces is 60. 60 as in, there was a block that was hung or suspended at the center, and it's the same center where the weight of this plank is acting. So the 2 gets us to 60. So I write 60 meters. So when I want to get TQ, that is the tension of Q, we say it is 60 minus 34.29. So 34.29, I mean 60 minus 34.29. I get 25.71. So TQ is equals to 25.71 newtons. So therefore, the tension on rope R is 34.29 newtons, and the tension on rope Q is 25.71 newtons. That is the answer. Feel free, learners, to ask questions in the comment section. Please, for the new learners, consider subscribing, sharing, and commenting on our videos. See you next time in my next video.